Right, so the first we're going to have a look at is the matrix here, which we worked out before, and we worked out the eigenvalues were 2 and 3, so we're just going to do it once for each one. So we'll start off with the situation where the eigenvalue is 2, and then we've got to say solve this equation, so let's write this equation down. So x, now remembering that x is a vector, so it's a 2-element vector, so this is a 2 by 2 matrix, so we can have a 2-element vector, and that has to equal lambda lots, and lambda is 2 in this case, so we get that. And now we can just set up a set of equations. So if we multiply this out, we get 4x1 minus x2 has to equal 2 lots of x1, and from the second row, 2 lots of x1 plus x2 has to equal 2 lots of x2. Okay, so we have a couple of equations, and the simplest thing to do here is just to make them easier to see. So I'll bring that 2x over that side and pop the x2s over to that side, and the same with this one. If I bring that x2 over to that side, I get 2x1 equals x2. Okay, and those two equations are the same. So any point where x2 is twice as big as x1 will do the job. So a eigenvector would be 1, 2, or in fact any eigenvector of the form t and 2t. Okay, so what this is saying is that any vector of this form, where the second element is twice the first element, when transformed by this matrix, will only undergo a linear scale, and in fact it will double because the eigenvalue is equal to 2. And if we repeat the process for the situation with the eigenvalue being 3, we can have exactly the same thing for 2, 1, multiplied by our vector, and it's going to have to equal the eigenvalue times the vector. Do the multiplication, so 4 lots of x1 minus x2 equals 3 lots of x1. Same for the bottom line, 2 lots of x1 plus x2 equals 3 lots of x2. Put the x1s over that side, so we get x1 equals x2, and here we're going to get 2 lots of x1 equals 2 lots of x2. Okay, so any point where these two things are the same, which follows on here, so the primary eigenvector would be 1, 1, but in fact anything of the form tt would work. And just to show you what I mean by this, let's just pick a random one, so, okay, like 5, 5. So if we take our original our original matrix, 2, 1, and if we multiply it by the vector 5, 5, it should come out to be 15, 15. So we get 20 minus 5 is 15, and 10 and 5 is 15. Okay, which is obviously 3 lots of 5, 5. So as long as our vector that we're working with is of this form, so it's an eigenvector, when we do the multiplication we get a vector which is exactly a scalar multiple of the one we started with, and the scalar of multiplication is the eigenvalue that we were working with.